Hello everyone. I am going to do a salary prediction model, that can predict salary for every employee given the information that they provide. The information that they provide, that will be the data set for my model that I will build. The data set will consist of the education background, work class of the person, the age, job title, hours worked, and many others, as you shall see in my dataset. The um, uh, the importance of the salary prediction is that it will be able to enable companies to predict the estimated salary to be given to an employee, and then it will also enable them to evaluate current salary for an employee and the potential job offers for an employee in a given period of time, and given the information that they provide now to us. This is how I will use artificial intelligence to solve my problem. I will apply supervised machine learning to build a mathematical model based on my sample data that I have already, and then such a model can make decisions and predictions. The sample data will train my model to make proper predictions on the salary, and then it's supposed to give accurate predicted results. I will use, as I said, that I will use supervised machine learning with the labeled dataset that I already have. That means that I will be able to use, I will use basically two types of supervised learning, that is classification and regression machine learning. And then where need be, I will include unsupervised machine learning. That one includes dimensionality reduction machine learning and clustering machine learning. What do I mean by classification machine learning? We said earlier that it is a supervised machine learning. This one classifies the algorithms in similar patterns, such that new inputs are also able to follow the same pattern. You will be able to understand this when I go ahead to implement my model. You will be able to understand what I mean by classification machine learning. And then regression machine learning will estimate the relationship between different variables of a given data set. And then dimensional reduction machine learning. This one shall be used to eliminate certain random variables in case my data set has high number of features. Then clustering machine learning, groups of similar objects in the dataset are identified. These ones all, I'm going to explain them in detail as we move on in the slides. The type of data that I will use to solve my problem, I will use numeric data and string data. This is because numeric data, I will have to input the age, the capital gains, the capital losses, and hours worked of that employee, as you shall see in my dataset. And then the string data will include of education, the work class, the marital status, occupation, and many others. Here I give the differences between supervised and unsupervised learning in detail. Now, supervised learning is a machine learning paradigm consisting of labeled data. What do I mean by labeled data? Labeled data, here I have the desired input that I have to put into my model for it to give me the expected output. Supervised machine learning, this means that I am able to know the kind of output that I should expect from my model. And then unsupervised learning, I do not know the kind of output that I will get from my model, and then I do not know the input that I'm supposed to feed into my model for it to give me output. Then now that means that I'll have to go into the field for unsupervised learning to get the different data or information from the different entities that I feed it into my machine for it to identify patterns in the datasets. containing data points that are neither classified nor labeled. Now, in supervised learning, we have regression, classification, Bayesian model, and the others. But in my model, I'll be able to use regression and classification machine learning. Then, in unsupervised learning, there is clustering and dimensionality reduction, association, and many others. But where I need be, I'll be able to use dimensionality reduction and clustering in my model, as you shall see in the slides. Here I explain deep what regression machine learning and classification machine learning mean. Regression machine learning has an example, which is linear regression. This finds the linear relationship between the dependent variables and one or more independent variables. Here I will have to feed in my information into the model, and then it will have to find the relationship between my dependent variables, and the independent variables. We are saying that regression is a machine learning model which estimates the relationship between variables. The model is trained with both input data and output labels. Then classification machine learning, that is a type of pattern recognition in which classification, or you can call it categorization, of algorithms are performed on training data to discover the same pattern in the new dataset. Meaning that this machine of mine, this model of mine that I'm going to implement, once I train it with my own dataset that I have currently, then I'll have to use new datasets so that I could find out its performance. So it's supposed to still give me the same pattern recognition as it did in the very first implementation. So that is classification machine learning. Then the two unsupervised learning and how I will use them. Now there is clustering. Clustering is the process of grouping similar entities together. Data with similarities in the data points are grouped together. This helps profile the attributes of different groups. Now the other, I will use dimensionality reduction. This is a machine learning technique of reducing the amount of random variables in a problem by obtaining a set of principal variables, meaning that in my data set, if in case my variables are many or are too many, then I'll have to reduce them using dimensionality reduction to make decision and prediction easier for my model. Now the challenges that I expect to face in my project are that I need to first understand the basics of Python. I need to get to understand how to the real syntax of Python, how to work with Python to build my model. And then I'll face classification problems, because classifying fields into a group that is of the same class may be difficult. Then testing the performance of my model basing on different datasets, because these datasets have different quality. So I may have my dataset may perform well, but then if I go ahead to use another dataset, the model may fail. It may fail or give me unexpected results. And then calculating the accuracy or the predicted score of my model when I feed in input, that may also be a challenge. Possible solutions to the problems that I may face are that I should specify the field that contains the classes that I want to predict, and that the classes shouldn't be very many to make classification job easier. And I hope you understand that it says that I should specify the fields that contains the classes. Here I'll have to use dimensionality reduction to reduce on the number of variables, such that I make the classification job easier. Yeah. Then I need to understand the syntax for feeding in data using Python. As I said, Python basics, I need to understand them. Then I have to understand how to work with the confusion matrix so that I can predict well, so that my model can predict well, based on the data that I will input. There is accuracy. There's a difference between accuracy, recall, and precision and F1 score. Now, accuracy is used to find the portion of correctly classified values, tells how often the classifier is right. That means that you have to get the true negatives plus the true positives divided by all the output. That's the true positives, the true negatives, the false positives, and the false negatives. I go ahead to find accuracy. Then recall, it is used to calculate the model's ability to predict the positive values, meaning that I have to get all the true positives, and then I divide by the true positives plus the false negatives. There I will be able to find the positive values. Then precision, it is used to calculate the model's ability to classify positive values. How often is this? Means that how often should my model predict right, or how often should it is the model right when it predicts the positive values. That means that I have to get the true positives, and then I divide by the true positives plus the false negatives. Now the F1 scores, it is the harmonic mean of recall and precision. Now the F1 score, it gets both the precision and the recall at the same time to give out the score. Now the F1 score is calculated as 2 multiplied by the precision, then by the recall divided by precision plus recall. That one will do my F1 score. Then I think that is it. Then if you need the references for my work, my references are just above, and then you can go ahead and check on the confusion matrix using the very first link, and then I use Dix4Gix, I use Kaggle, I use Sense, and many others, and you can get information. I guess that's it. Thank you.